In this video, we are going to focus our discussion on how to find the area of triangle in relation with related rates. On the first example, the base of a right triangle is increasing at 3 cm per minute, while the height of the triangle is increasing at the rate of 5 cm per minute. How fast is the area of the triangle changing when the base and height are 8 cm and 6 cm long respectively? So the first step that we're going to do to answer this question is to illustrate the given problem. So let us have a right triangle. So this will be the base and this will be the height. And the area of a right triangle is 1/2 base times height. And we have a given base that is 8 centimeters and a height of 6 centimeters. And then the base of the right triangle is increasing at 3 centimeters per minute. So that is dB over dt. That is 3 centimeters per minute. And then the height of the triangle is increasing at the rate of 5 centimeters per minute. And that is dH over dt. That is 5 centimeters per minute. Now, what we have to do to calculate how fast the area of the triangle, we are going to differentiate both sides of the equation with respect to time. The derivative of a, that is a constant, that is 1. And then we have dA over dt. And then we have a product rule. So u, that is 1/2 base, and then v, that is h, and then u prime, that is the derivative of 1/2 base with respect to time, that is 1/2 dB over dt, and then v prime, that is the derivative of h with respect to time, that is 1 dH over dt, and then product rule, that is u prime times v plus u b prime. So u prime, that is 1/2 dB over dt, and then v, that is a height, and then u, that is 1/2 base, and then v prime, that is dH over dt. So let us substitute this one. Let us have 1/2 dB over dt multiplied by height plus 1/2 base multiplied by dH over dt. And then let us substitute the given. So let us have dA over dt. So let us have 1/2, and then dB over dt, that is 3 centimeters per minute, and then height, that is 6 centimeters, plus 1/2 base, that is 8 centimeters, and then dH over dt, that is 5 centimeters per minute. So 6 divided by 2, that is 3, and 3 centimeters times 3 centimeters, that is 9 centimeters square per minute. And then we have 8 divided by 2, that is 4. 4 centimeters times 5 centimeters, that's 20 centimeters square per minute. So therefore, dA over dt, that is 9 centimeters square per minute plus 20 centimeters square per minute, that's 29 centimeters square per minute. And this will be our answer. On example number 2, a triangle has two sides of fixed length which are 5 meters and 8 meters long. The angle between them is increasing at the rate of 0.20 radians per minute. How fast is the angle of the triangle changing when the angle between the two sides is pi over 3? So let us illustrate first the given problem. So if we are going to have a triangle A, B, and C. Across angle A is side A. Across angle B is side B. and across angle C is side C. And the formula to find the area of this triangle is area equals 1/2 A times B multiplied by sine C. All capital letters represent an angle, and all small letters represent sides. And then, let us represent two sides of the triangle as A and B. So the value of A is 5 meters, and the value of B is 8 meters. And the angle between A and B is angle C. So let us have theta here, and angle C, that is pi over 3. And then, the angle between them is increasing at the rate of 0.20 radians per minute. So the derivative of C with respect to time, that is dc over dt, that is 0.20 radians per minute. And then, we are looking for dA over dt, that is the area. So as you can see, we don't have a value for dA over dt and dB over dt because of this statement. Because the given problem, it says here, the triangle has two sides of fixed length. That's why A and B are constant. So therefore, let us differentiate both sides of the equation with respect to time. The derivative of A with respect to time, that is dA over dt. And then we have 1/2 A, that is 5 meters, and then B, that is 8 meters. And the derivative of sine, that is cosine C with respect to time, that is dc over dt. So let us have 1/2 times 5 meters multiplied by 8 meters times cosine pi over 3, that is the value of angle C, and then dc over dt, that is 0.20 radians per minute. So let us simplify. 8 meters divided by 2, that is 4, and 5 meters times 4 meters, that's 20 meter square. And then cosine pi over 3, that's 1/2, and then we have 0.20 radians per minute. So let us simplify. 20 meter square multiplied by 1/2, that's 10 meter square, multiplied by 0.20 radians per minute. So our final answer is 10 meters square multiplied by 0.20, that is 2 meter square per minute. And this will be our answer. So I hope you learned from this lesson. If you like this video, just like and subscribe to be updated on my next tutorial lesson. Thank you so much for watching, and God bless us all.